Hello and welcome back to the Cracking Fan YouTube channel. Today we're doing a super easy problem, 266 palindrome permutation. Given a string S, return true if a permutation of the string could form a palindrome and false otherwise. For example, if we're given S equals code, we should return false because there's no way you can make this into a palindrome. If we have AAB, then you can make this into a palindrome by doing ABA. And we can do char rack, which actually already is a palindrome, so that one's fine. We're also told that the string can only consist of lowercase English letters, which makes our life really easy. Now, let's remember how you actually form a palindrome. A palindrome basically needs to have all characters of even count, and you can have one char with an odd count. Because if you had something like BB, AAA, BB, this is fine because it's a palindrome around the center, right? You're allowed to have one that has an odd length, and that's fine. So all we need to do is basically keep track of the count of our characters, and at the end, if we have any characters whose count is odd, and this count of those odds is actually greater than 1, then we know that we cannot form a palindrome. So we're just going to say char counts. We're going to basically just initialize a dictionary, so default dictionary and int, and we're going to keep track of basically the counts, and then we're going to do an odd count to keep track of our odds. This is going to be 0. Now we're just going to go character for character, so we're going to say for char in S. What do we want to do? We want to say we want to add it to our dictionary, so we're going to say char counts char. We're going to add it by 1, and now we're going to say if char counts of char modulo 2 equals to 0. So basically, if it's even, then we want to say that the odd count should get decremented by 1. Otherwise, if it's odd, then we obviously want to increment the odd count. So we're going to increment the odd count by 1. And there we go. We move on to the next character, and eventually we'll process the entire string. At the end, all we need to do is return whether the odd count is less than or equal to 1, and that will tell us whether or not we have a palindrome. So let's run this, and looks good. We can submit this, and we are accepted. Cool. So quickly, let's just run through the time and space complexity. So for the time, obviously it's going to be big O of n because we need to process every single character in our string. So this is just going to be big O of n, where n equals num chars in S. And for the space complexity, it's going to be big O of 1. We do have this dictionary here, but remember, because our problem is actually constrained, oops, nope, that's the solution. We're actually constrained to only the lowercase English letters. The amount of keys in our dictionary will only be 26. Which is a constant space allocation. Since we know it up front, it doesn't actually depend on the input. We know that maximum will ever have only 26 keys in our dictionary. So this is really just constant space. Cool, so that's how you solve this problem. If you enjoyed it, why not leave a like and a comment, subscribe for more videos, and I'll see you in the next one. Bye.